Okay, we've already dealt with points, we've dealt with lines, we've dealt with line segments, and we've dealt with rays. So now that we did that in Basic Geometry 1. So in Basic Geometry 2, let's look at something else. We only had 2 points. What happens if we have 3 points? And notice they are not collinear. As a matter of fact, I could create a triangle with these 3 points. When we have 3 points that are not collinear, so what does collinear mean? Collinear means they are on the same line. If they're not collinear, that means they are not on the same line. And would you not agree that I cannot just make one line? Can't draw a straight line anyway, but I cannot make one line with this. I'd have to make at least 2. So when they're not collinear, then we have what they call a plane. So this is a plane. Similar to a regular just sheet of paper. Okay? Similar to a regular sheet of paper. Now, a plane has length and width, and it has some thickness. So we can also consider looking at the sky. That would be considered a plane. The earth that we walk on, that would be considered a plane. But we must have 3 points that are non-collinear. Not on the same line. Does that help? No, I'm missing something. Points. Not on the same line. And you agree that that's it. Now, generally they name a plane with a cursive. So let's say R. So that would be plane R. So a cursive capital letter is how they name a plane. Well, in addition to that, we talked about one line. We talked about a ray. And what would happen if we put 2 rays end to end? So this is ray A and B, and let's do another ray A and C. What did we create? We have created an angle. When you put 2 rays together, whoa, 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 gator mouth. Okay, I'm in Florida, so help me out of here a little bit. All right, if you put 2 rays together at one end point, we create an angle. Now, let's describe all parts of this. This would be considered the initial side. So this ray would be the initial side. And then we would have our terminal side. So this ray is our terminal side. All right, and notice that the arrow connecting the 2 is pointing toward the terminal side. So the angle is in degrees. And we use this little symbol, that little circular symbol means degrees. All right? So, when we talk about angles, we have to discuss a couple of things with angles. What do we have to discuss? We have what they call acute angles. Angles can be acute, which means that it is less than 90 degrees. Or an angle can be obtuse, which means it is greater than 90 degrees, but less than 180 degrees. So that's one, and that's two. Well, an angle can also be a right angle, which equals exactly 90 degrees. So we have our acute angle, which is less than 30 degrees, this would be considered kind of acute. When you see a right angle, you should always look for that little box, or the statement of the problem should give you some idea and tell you that it is a 90-degree angle. Never assume that an angle is 90 degrees. Visually, from our eyes, we cannot determine whether that's 90 degrees, 89 degrees, 91 degrees, 92 degrees. So it's best that if there's no little box that says it's 90 degrees, or if the statement, the problem itself, the wording of the problem itself does not say that it is a right angle or 90 degrees, never make that assumption. All right, so now we had our right angle, exactly 90 degrees, our acute angle, less than 90 degrees, our obtuse angle, greater than 90 degrees, and then we have one more. Let me put my picture back here. We also have, if we put the two rays together in a perfectly straight line, then we have what they call a straight angle. So that is angle number 4. That's the type of angle number 4, which is exactly 180 degrees. Two 90s. 90 here plus 90 here gives us 180 degrees. Okay? So, that's our basic angles. We'll be back and we'll talk a little bit more about angles.